So this is going over the Chapter 3 free response review questions. And as always, it's just 2 questions, but the rubric from the College Board is 15 pages long. So I'll kind of scroll through and try to show you what is useful within that 15 pages. All right, so let's take a moment and review these computer outputs just to remind yourself how to find things. And again, just a reminder that the computer output stuff is on page 191 and 192 of the textbook. So if you have a paper textbook, it'd be a great place to put a little Post-it note so you can go back and look and see what to look up where. Or I did that PDF of it in class, and you could download that, print it out, or at least have it ready to get to on your computer so you can look it up. I'm not expecting that at this point you memorize where everything is. I expect you to look it up. Okay, so reminder that right here, this is the y-intercept, and this is the slope, if that was our equation. We have s in here. We have r squared, although if you were to do any calculations with it, you don't want it in percent form, you want it in decimal form. So r squared is really 0.1229. And reminder that if you need r, it's the square root of 0.1229, and it might need a plus or a minus. You have to look at the situation to decide, and that comes up, I think, in Part C. Okay, and then the last thing just to remind you of that all this stuff is end of the class stuff, like end of the year kind of stuff, so don't worry about it yet. And this adjusted, we never use. So the rest of this, just cross it out. Don't let your brain put any effort into it. Okay, so I'm going to scroll down to where they actually start talking about what they're looking for. So I'm on page 4 of the PDF now, where they talk about scoring. And again, they always score everything on free responses either essentially correct, partially correct, so you get half the points, or incorrect. And when I graded on my own tests, I put more levels in between. It's not full, half, or nothing. There's more options than that. Okay, but to get essentially correct, to get all the points, you need to correctly identify the numerical value of the slope, which I'm going to scroll back up because I've forgotten what it is 235. So 235 needs to show up in there. You need to talk about the slope as the change in attendance per game for each additional win, and context. So not just change in y for each additional x, but the context is talking in there. You're talking about attendance, you're talking about wins, there's context. And then the last piece is what they call non-deterministic language. So you're not saying that this least squares regression line can perfectly predict things, or can perfectly tell you what the real life answer is. It can only give you a prediction. So predicted is a kind of word they're looking for. Or if you scroll down a little bit more under notes, they say examples of non-determinist language. So predicted would be good, expected, estimated, average, that kind of thing. They would not want things like about or approximately. This is not an ly word kind of thing. They want you to say that it's what's being predicted out of the least squares regression line. Okay. And then if you have all 3 of those things, you get full credit. If you got 2 of those 3, then you get partial. And if you have less than that, you get incorrect. Okay, so we keep scrolling. Now we're on to part B, where it's about extrapolation. The fact is x equals 0. 0 wins is so far away from the data you have that you can't assume the pattern works all the way out there. So here is their kind of example solution. But to get full credit on this, you need to mention that the x values used to create the model. So the x data that we have does not include 0. They want you to say what x data we do have. We have between 64 and 104, and 0 is not part of that interval. So that sentence I just said would hit both those bullets. And they need some context in there. So at least one of the variable names. Number of wins or attendance per game. Notice they didn't require the word extrapolation. Their answer their kind of perfect answer, use that vocab word. But if you don't use that vocab word, but instead describe the concept of it, you're still fine. Okay, part C was understanding that the 0.1229 was r squared. You get that out of the output. Square root it, you get the number part of r. And then how do you know if it's positive or negative? I'm going to scroll all the way back up to the top. You can see that that is a positive slope. You can see that it's going up. You can see that when they gave us 235 as our slope, that's a positive number. So that means, let me get back down there. I'm probably making you sick with all this scrolling. There we are. It's positive because the least squares regression line has a positive slope. And you could have seen that in the graph, or you could have seen that in the computer printout by the fact that the slope is a positive number. Okay, so they need the correct value and they need supporting work. So they need to see the square root of 0.1229 to get full credit for that. Let's see. Okay, now we're down to part D, which had two parts, a part of a part. Okay, so if the outlier was removed, let's see. Let me scroll back up to the top again. So 60, so this is our outlier. So thinking about what this would do if you took it out. Remember, I'm just going to kind of talk about the concept first, and then we'll go look to see how they graded it specifically. And remember that there's a fulcrum here, and I'm guesstimating where this is, around X bar, comma, Y bar, and it teeter-totters around that. And right now, this outlier is pulling the teeter-totter towards it. So if you take that outlier away, it would not have that force pulling it in, and it would like pop. Whoops. Hang on. Oh dear. Here's my teeter-totter. So if you take that outlier away, it's going to kind of not be pulled up anymore. So there's kind of, it would snap down a little bit, and it would teeter-totter that direction. So that means your slope becomes bigger. It's more steep, bigger slope. That means our y-intercept has gotten smaller. It would hit the y-axis at a lower spot. And the correlation, okay, this outlier is outside the pattern of the points. So it is making the correlation worse. It's making the correlation smaller. It's making it seem like the points don't fit the line as well. But if we take out our worst fitting point, now it seems like the points fit the line better. So that gives us a higher correlation. Okay, so that kind of talked through all the concepts there. So let's go down to where they talk about specifically what they need to give you all the points. Okay, so here's their official solution. But let's go down to the scoring. So to be essentially correct, you need to say that the slope would be steeper, or you could say higher number, and an explanation based on the location of the identified point relative to the other points. So if you talk through what I just said, that outlier is no longer pulling that end of the line up, which makes the end of the line snap down, which changes how it relates. And I think what they said was because the point is to the left of X bar and above the least squares regression line. So they didn't even really talk about the concept much. They just talked about the location and saying that means it's going to snap back up. Okay, and then the last part, here's their perfect solution, but it's only one way to write it. So to get full credit on that, you would have to say that the correlation coefficient, that's R, would be greater, closer to 1 or stronger, different ways you could say it. And again, an explanation based on the location of the point relative to the other points. So what did they say? Because points outside the linear pattern, correlation would become better, would become stronger, higher number if you took that outlier out. If that was an outlier that was within the pattern of the points, it would have the opposite effect. Okay. Okay, so on to question 2. So I am now on page 8 of the PDF. And I'm going to kind of show their official solutions first, but then we'll talk about how to score it. So part A, they wanted you, here's our graphs. They wanted you to describe, no, up here. They wanted you to describe the correlation. So this is a Duff's problem. Direction, unusual features, form, strength. Direction is positive, because you can imagine a least squares regression line here. So positive, I don't see any outliers. Form, linear, seems reasonable that's linear. And strength, let's see what they said. I would call that moderately strong, but let's see if we agree. Yeah, oh, look it. Moderately strong, positive, linear. Okay, so then let's go down to scoring. Okay, so I'm on page 9. So to get it essentially correct, they need approximately linear, they need positive, they need moderate to strong association. So they were okay with moderate, they were okay with strong, they were okay with moderately strong, and you needed context. So if you had all those things in your sentences, then you were good on part A. That's your Duff's. Part B, they want the line in graph 2. So actually, I'm going to scroll back up to it and talk about why first, kind of informally, and then we'll talk about how they would have graded it. So here is your least squared regression line on graph 1. And then graph 2 has the line y equals x. And just thinking back to algebra, that's the line y equals 1x plus 0. So we're talking it goes through 0, 0. If it went down to 0, 0, and it has a slope of 1. It goes up 1 over 1. So it's a perfectly diagonal line if your x and y scales are the same. And what's nice about that line is anything on this line is when the height and arm span are the same. They match. You know, like this, I don't know, this point here would be 62, 62. So height is 62, arm span is 62. So that's kind of the break point between being not perfectly matched. From between arm and height. So anything up here has big arms and small height. So this has big arms, small height. Imagine something way up here extreme. That would have a very small height of 60, but a big arm span of 72. And then below the line has small arms, big height. Imagine a really extreme point over here. Would have a big height of 72, but a small arm span of 60-ish. Okay, so really this line breaks us up into our squares and rectangles. Okay, so now let me go down to how they would score it. Where are we? Oh, it's so easy to get lost in these. Okay, so the line in graph 2 is one of the things they're looking for. Your answer is graph 2. They're looking for a reasonable explanation as to why that is the right answer. And you could talk about the things I just talked about. Talking about above the line is a tall rectangle. Below the line is, below the line is tall. Above the line is, what do they call it? Short rectangle. And along the line, exactly on the line, is a square. Then they looked a little bit down to the next part where you're filling out the table and making sure that you have the correct frequencies in there. And by the way, they let it be okay if you wrote it as a fraction or a proportion. That'd be fine too. And yeah, they need the correct frequencies. I'm not totally clear on why those are two different bullet points, but so those are all the things they're looking for part B. And you can get into all these detail of like, you know, what would be officially okay on a lot of things in the middle. Okay, so then for part C, let me scroll up to show their actual answer since you're kind of just checking numbers. So this is what they would look for. 3 square, 4 tall rectangle, 5 short rectangle. And then part C, you're really just plugging 61 in for X in the least squares regression line and getting an answer. And that's kind of all they're looking for there. So let's look at how they scored it. So for part C, it needs to have the correct formula, and you're plugging 61 in for X. You need the correct answer, and you need units on it. and that would get you full credit. Okay. Is that it? There's only 3 parts, right? Yep, that's it. All right. Gerlicher out.